Hello PLP geometry, we've made it. The final video of unit 1, right? We're going to continue with these geometric proofs. I'm going to give you a couple more just to kind of get you a couple under your belt. Then you got the paper and pencil assignment doing some proofs. So again, this is the last video of unit 1, your introduction to geometry. So again, now you're all pros, right? You're ready to learn the big stuff. So again, this is number 12B. And again, we're doing geometric proofs again. Okay. So what this video is going to focus on is proofs involving parallel lines. So we're going to look at some parallel line proofs. In geometry, in the class, our main topic that we do a lot of proofs with are congruent triangles. That's a huge deal in this class, right? But to get you to warm up to them, we're going to use parallel lines and do some proofs. So parallel line proofs. So let's recall back from video 9, 10, maybe video 10, right? If parallel lines are cut by a transversal. So if we have a picture and we know that two lines are parallel and there's a transversal involved, then we know 4 things. 1, 2, 3, 4. First, we know that corresponding angles are congruent. We know that alternate interior angles are congruent. We know that alternate exterior angles are congruent. And the last one, and the little bit different one, we know that same side interior angles are supplementary. So that is if you are given. So say this is what we are given. Okay? If we're given that lines are parallel, then we know these things. Well, we can also do it backwards. Say that we're given a picture where we don't know the lines are parallel, but we do know one of these relationships is true, or we can prove. So I shouldn't say given, but I should say we can show. So let me erase this, sorry. So if we are able to show that one of these 4 relationships is true, then these arrows can go in reverse as well. We can then prove that the lines are parallel. We can arrive at that idea. So these relationships go forward and backwards. So we're going to do a proof where you're given lines are parallel, and then we're going to do a proof where you have to prove lines are parallel. Okay? And again, we're going to use the properties and kind of give you all kinds of situations that you might need. All right? So it'll be a good thing. All right. So let's take a look at this first proof here. So again, we're doing a proof. And again, for this proof, we're going to be given lines parallel. Okay, so given line L parallel to line M. And I'll draw that picture over here. So here's L, here's M, there's transversal T. And again, I'm only going to give you the angles you need to know. So angle 1, angle 2, and angle 3. I want you to prove that angle 1 and angle 3 are supplementary. Well, you might say to yourself, well, Mr. Chappell, duh, they're supplementary, because if the lines are parallel, those are same side interior angles, so they're going to be supplementary. So we're not going to use that, okay? So again, don't use Same side interior. And again, I will try to hint that on the proofs so you know what not to do. Because if we just use that, it'd be a one-step proof. We wouldn't need angle 2. All right? Okay. But everything else is fair game. Okay? All right, perfect. So let us draw our 2 columns. So I have my statements right here. Again, you can just use an S if you want to. Statements. I have my reasons over here. And again, I would just make it as wide as what you're given, or what between the given proof and the diagram. Okay. All right. So statement 1 is always what you're given. We are given that L is parallel to M, and that is given to us. So in my picture, I'm going to mark L parallel to M with the arrows. So now, if we look at the picture, as I said, angle 1 and angle 3 are same side interior angles, but we're not going to use that, right? What other relationship do I see between my angles that are based off parallel lines? Well, what about angle 1 and 2? Angle 1 and 2 are alternate interior angles. I see alternate interior angles, so I'm going to use that as my next statement. So I know that angle 1 is congruent to angle 2, because if lines are parallel, that's my symbol for parallel. So let's do this, sorry. Let's put if. If lines parallel, it doesn't really matter. I mean, it's semantics, right? I get caught up in the semantics sometimes of this. If lines parallel, then alternate interior angles are congruent. And there you go. And I can mark them congruent using an arc mark on angle 1 and angle 2. Perfect, right? Okay, so that's what we can gather from the fact that we have parallel lines. So now, we have angle 1 in the proof, but we have angle 2. So now the question is, how are we going to get angle 3 into this proof? Well, let's look at the picture. Is there a relationship between angle 2 and angle 3? Well, right here, look at angle 2 and angle 3. They make line M. They are a linear pair. That makes them supplementary. So in step 3, I know that the measure of angle 2 plus the measure of angle 3 equals 180. This does not have to do with parallel lines, right? This has to do with linear pairs. Linear pairs are supplementary. Now, let's talk about what we have right now, right? We have angle 1 and angle 2 are equal. They're the same, right? They're congruent. And we have angle 2 and angle 3 add up to 180. So they're supplementary. So if you look at this, it would be nice, right? It would be nice if we could replace angle 2 with angle 1. Because look, we want to prove that angle 1 and angle 3 are supplementary. If we can put angle 1 here and say that it adds with angle 3 to make 180, that would make them supplementary. Well, we can, but it takes a couple more steps. So I apologize. This is where kind of the semantics of this comes into play. So this statement is about congruence, right? It has to do with congruence. This statement is about equality. You can't mix and match. So what we're going to do is we're going to change statement 2 from congruence to equality. So in step 4, we're going to make it very similar to angle or step 2, but we're going to say the measure of angle 1 equals the measure of angle 2. We can go back and forth like this because we know that congruent angles, so in step 2 we were given congruent angles have equal measure. Equal measures. Okay, so now we can do the substitution. Now I see angle 2 here, the measure of angle 2 here, and here. The measure of angle 2 is equal to the measure of angle 1. So we're going to go ahead and replace angle 2 with angle 1. So we're taking step 4 and substituting it into step 3. So my 5th step here, and again I'm sliding in because of my little menu down here. So we're going to say the measure of angle 1 plus the measure of angle 3 equals 180. So essentially I took out angle 2 and replaced with angle 1. This is called substitution. Substitution, and again, property if you want to be appropriate. Property. Now I am almost done, right? Because I have the fact that the measure of angle 1 and angle 3 add up to 180. That's what it means to be supplementary. So I just need to say that as my last step because that's how they want it to be presented. So I'm going to put step 6 up here. I'm going to erase so I don't have to leave the whole screen. Okay? So again, you keep working down. I'm going to put it right there. And again, this is just so I don't have to leave the screen. So step 6, we would say that angle 1 and angle 3 are supplementary. And then there's my bar for my reasons and statements. And for reason 6, we would put something like angles whose sum equals 180 are supplementary. Angles whose sum equals 180 are supplementary. And that's what it means to be supplementary. You could pretty much just put the word supplementary or, supplementary equals 180, something like that, and I would be good. Okay, so there's your first proof where you're given lines parallel. Okay, and now let's try one where we are given or not given the lines are parallel. Okay, so this is our second proof of the video. This is to prove lines parallel. Okay, so in this proof, we are going to be given that angle 1 is congruent to angle 2. And let's look at this picture here. So this is going to be a line L. This is going to be a line M. Here's my transversal. Call it T. I'm going to give you these 3 angles, 1, 2, and 3. Based off of that given and what you can find out from the picture, I want you to prove that line L is parallel to line M. Okay? So if we take a look, let's draw our statements and reasons, 2 columns. Wish I had more room. So I apologize if I feel like I am writing small just because I'm trying to cram it all in there. So statements and reasons. You guys don't cram it in, right? Okay. So in this problem, we are given that angle 1 and angle 2 are congruent. So we can mark that and say that. So in the first statement, we're going to say angle 1 is congruent to angle 2. That is given to us. Now, of course, these are these are alternate interior angles. And if we know all alternate interior angles are congruent, then we know the lines are parallel. So we technically know the lines are parallel, but do not use this. Okay? I want you to have to use angle 3 in another way. Well, if you look at this picture, the other special angle pair would be corresponding. 2 and 3 are corresponding. So our job is to show that those 2 angles are congruent, and then we can say the lines are parallel. That's how it works with proving lines parallel. Show one of those 4 relationships, and once you do, then you can say the lines are parallel. Okay? All right, but we have to arrive at that, right? So right now we can say nothing else about things being congruent or supplementary based off of parallel lines because we don't know L and M are parallel. But if you look at this picture, there's another angle pair relationship up here, right? 1 and 3. 1 and 3 are vertical angles. If you trace those 2 lines, right, these are vertical from each other. So we know that angle 1 is congruent to angle 3. I'm going to mark angle 1 with another single green arc and mark 3 with a single green arc. So now you can see that all 3 angles are going to be congruent to each other, right? And that helps you in your proof. This is again because vertical angles are congruent. Has nothing to do with parallel lines. All right? Well, now look at statements 1 and 2. They both have angle 1 in common. Angle 2 is congruent to angle 1, and angle 3 is congruent to angle 1. This is the transitive property. Angle 1 is transitioning 2 and 3 to each other. Because angle 2 and angle 3 are both congruent to angle 1, that means that angle 2 and angle 3 are congruent to each other. This is because of the transitive property. It's what we did with steps 1 and 2 to arrive at step 3, statement 3. So this is the transitive property. I'm going to just trace over their congruence markings. Again, they're just single markings because they're all congruent. And now, what we've shown is this. We've shown that angle 2 are congruent. Angle 2 and angle 3 are congruent. Angle 2 and angle 3 are a pair of corresponding angles. Because we showed that pair of corresponding angles congruent, we can now say that the lines are parallel. And that's going to be our last step. Step 4. We can now say that line L is parallel to line M. And this is because if corresponding angles are congruent, then lines are parallel. A lot of students want to use corresponding angles as the reason in step 3. That is not why the angle 2 and 3 are congruent. The angle 2 and 3 are congruent because of what you said in steps 1 and 2. So do not make that mistake. This must be the last reason because that is what proves the lines parallel. Again, this is going to be a tough topic. I get it. All right. So again, I'm going to have a lot of paper and pencil examples. Just work through them, do your best, and we'll get through this together. All right. Congratulations on getting to the end of Unit 1. Right? You did it. Hopefully it wasn't too bad, and good to go.